second problem, we have to determine the velocity of water. We have a huge water tank with a hole 16 meters under the water level. Uh, so we have to determine the velocity of the hole of the water flowing out of the hole and the diameter of the hole. Uh, we have to know that as this is a huge area and this is a low area, the velocity of this is going to decrease in a very little way. So we're going to take that V1 is approximately 0, and P1 and P2 are both to 1 atmosphere. So when we do the Bernoulli's equation, we can get rid of them. We have that the Bernoulli's equation is P1 plus 1 half of gravity, no, plus 1 half of density times V1 squared plus density times gravity times height equals P2 plus 1 half of density times V2 squared plus density times gravity times height. As we take this is we're going to take it as 0. P1 and P2 are going to be also, we're going to take them out. And we're going to then substitute here. We have, for the first case, that the water, this is going to be our origin point, so we're going to take this as x equals 0, where the hole is. So this first point is going to be density, is the density of water, times the gravity, times the height. This would be equal to 1 half of the density, which is also 1000, times dV2 plus the density times the gravity, and this is going to be 0 also. And then after isolating for V2, we're going to get that V2 is equal to 17.7 meters over second. Then we're going to determine the area, well, the diameter of the hole. For that we need to take the continuity equation. A1 B1 equals A2 B2. And if we take any one of these, it's going to be the flow of the rate flow. So we're going to take this A2V2 as this is the area we want to discover, and we're going to equal that to the flow rate. It's going to be A2V2. The flow rate is given in minutes, in meter cubes over minute. So we need to divide it by 60, getting 4.167 times 10 to the minus 5 meter cubed over second. So the flow rate is going to be 4 times 10 to the minus 5 equals area 2, which is the one we're looking for, times V2, we know it, so it's 17.7 meters over second. We're going to get this dividing, and we're going to get that area 2 is going to be equal to 2.354 times 10 to the minus 6 meter squared. And we're going to take the hole as a circular shape. So this is the area of this hole, and this hole has a diameter and it has a radius. The formula of the area is going to be pi times radius squared. We're going to find the radius, we know the area, so it's going to be 2.354 times 10 to the minus 6 over pi. Square root of that is going to give us the radius. And the radius is going to be 8.656 times 10 to the minus 4 meters. And as the radius is the diameter divided by 2, we're going to multiply this times 2. So finally we got that the diameter is equal to 0.000 meters, and this is equal also to 1.7 millimeters, the diameter of the hole. And we're done with the column.